In section 6.8, one of the topics that we talk about is Pascal's triangle. And there's a couple of things that I want you to take away from this lesson. One of them is how to make or construct Pascal's triangle. And then we're going to see how the triangle can be used to expand any binomial raised to any power, such as my binomial here at the bottom of the screen, x plus y being raised to the third power, if it is expanded out, would result in these four terms. Well, I want to show you using the triangle how that works. Okay, so first of all, it is important that you understand how the triangle is made. So it starts off with a single number 1 at the top. The next row will have two ones. So notice we start with one number, and now we have two numbers. And the next row is going to contain three numbers. And we're going to start using a pattern at this point. And the thing to remember is that every row starts and ends with 1. And the way you fill in the numbers between is you just look up and you add 1 plus 1 is 2. Okay, that's the third row. The fourth row will look like this. We start with 1, 1 plus 2 is 3, 2 plus 1 is 3, and then we end with 1. Okay, the next row starts with 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and we end with 1. Okay, and we just keep on doing the same pattern. Start with 1, 1 plus 4 is 5, 4 plus 6 is 10, 10 again, 4 plus 1 is 5, end with 1. All right, and we'll do one more. Start with 1, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and we'll end with 1. Now each one of the rows of the triangle corresponds to a particular exponent. So in other words, when you're given a binomial raised to a certain power, you'll look at the power and that will direct you to the row of the triangle that you will need to use for the expansion. Okay, and it works like this. The top row will correspond to an exponent of 0. And that makes sense because any number or binomial raised to the 0 power is always 1. The next row that contains the two ones corresponds to an exponent of 1. So if I had a binomial raised to the first power, this would be the row that I would look at, even though I probably don't have to look at it for something that easy. The next row corresponds to an exponent 2. This next row corresponds to exponent 3. Now let me stop here for a second. You notice how this binomial has an exponent of 3. And if you compare the row of the triangle that corresponds to exponent 3, do you notice something? These numbers represent the coefficients in the expansion. Okay, keep that in mind. That's going to become important in just a moment. So my next row corresponds to exponent 4. And this is exponent 5, exponent 6. And we could keep on going. Obviously, we could do this and never stop. The triangle just keeps on forever and ever. Depending on what exponent it is, we will build the triangle to help us with whatever the exponent of the binomial is. Okay? So let's just take a look using this binomial x plus 3 cubed. Let's just work through how we would use the triangle to come up with this expansion. Okay, so let me just back up and we'll create a new slide. Here's x plus y to the third. And again, let me just put the triangle up real fast. And I'm not going to put the whole triangle, but I notice that I've got exponent 3, so once again I'm going to go to this row of the triangle that has the 4 numbers, 1, 3, 3, 1. Something to keep in mind that when you expand binomials, your result, your final expansion, will always contain one more term than the exponent is. So for exponent 3, when I'm finished, I should have 4 terms, and that is the case here. So here's how the triangle works. I'm looking at the row of the triangle that corresponds to exponent 3, and this is the process. I start with the number from the triangle that represents the coefficient, and then I'm going to multiply that. Looking inside the parentheses, this first variable will be raised to this power. So x will be raised to the 3rd. Then I'm going to multiply the second variable, which in this case y, will be raised to the 0 power. Okay, and this is the way you always start from the number from the triangle. First variable will always start off being raised to whatever this outside power is, and the second variable or number, whatever the case is, will always begin by being raised to the 0 power. Okay, and then we just work on a pattern. The next number of the triangle is 3 times, now the first variable x is going to go down by 1, and the second variable y is going to go up by 1. So the first variable or number goes down, the second variable or number goes up. Okay, and I'm going to come back and clean all this up in just a moment. Okay, next number of the triangle is also 3. The first variable counts down by 1. The second variable counts up by 1. And then finally we get our last number of the triangle, which is 1. The first variable counts all the way down to 0, and the second variable counts up to 3. Now I wouldn't want you to leave this answer like this. This is just going to help us, first of all, see the pattern of these exponents, how the first one goes down and the second one goes up starting at 0. But to simplify this, y to the 0 power is just 1. And when we simplify all this, this would become x to the 3rd. Okay, and then I'm just showing that all of these are multiplied together, but my final answer really should just look like this. Don't really need exponent 1. Same thing here. I don't really need exponent 1. I just wanted to show you how the exponents count down and count back up. And then finally, 1 times y cubed is just y cubed. So that's how the Pascal's triangle works when it comes to expanding binomials to any power. All right. That's just some patterns that exist. This is one particular pattern. I won't take the time to do this, but if you're interested, if you're curious, you could Google patterns in Pascal's triangle, and there's all kinds. People have discovered all kinds of different just natural patterns that exist within the triangle. All right, let's try another one. So here's a binomial, a plus b raised to the 5th power. So you notice I've identified the row of the triangle that I will use to do the expansion. Okay, so here is the row. And let's begin. So it starts by choosing the first number from the triangle, which is 1, times the first variable in the parentheses will begin by being raised to the 5th, and the second variable will start off at the 0. Okay, number from the triangle, which is 5, times a goes down, and b goes up. Okay, next number from the triangle, a goes down, b goes up, and I'm going to continue down here, plus next number of the triangle, a goes down, b goes up. Next number from the triangle is 5, a goes down to the first, B goes up to the 4th, until finally we have our last number of the triangle. A goes all the way to 0, that is important, and B goes up to 5. So once again, you've got this is like showing work, but don't leave your answer like this, because this first term is really just a to the 5th. And then you have 5a to the 4th b, and then 10a cubed b squared, 10a squared b cubed, 5ab4, and then finally, again, this would just be b to the 5th. 1 times 1 times b to the 5th. So this would be your final answer. Okay, let's try another one. Let's see what happens when one of these terms inside the parentheses is actually a number. Okay, so here's my triangle. You don't have to write the triangle every time. You can just write a big one that will handle the largest exponent in your assignment, and just use that one triangle would be okay. I went ahead and marked the row of the triangle that we're going to need for exponent 4. I notice it's got 5 numbers because I will have 5 terms when I'm finished. So here we go. Number from the triangle times the first term, x raised to the 4th, times the second term, 3 raised to the 0. Okay, number from the triangle, x now will go down by 1, 3 will go up by 1. Next number from the triangle, x will go down, 3 will go up, and all these are multiplied together. Next number from the triangle, x will go down, 3 will go up, until finally I get my last number coefficient. X is now down to 0, 3 goes up to the 4th. Okay, simplifying, maybe I can change some colors here. The first term, if I simplify this first term here, I'm just going to get x to the 4th. Now notice this is a little different than what we ran into before, because I'm actually able to do some multiplication that was not possible in the previous problem. All right, 3 to the 1st is just 3, but I'm able to multiply 3 times 4 here to make 12 x to the 3rd. Okay, now working on this term, remember to do powers before you do multiplication. So I'm going to make 3 squared become 9, and 9 times 6 is 54x squared. Okay, 3 to the 3rd is 27, and now I'm able to do 27 times 4, which is 108x, until finally I'm left with 1 times 1 times 3 to the 4th, and 3 to the 4th is just 81. So I wanted to show you an example of when one of your terms is a regular number and how that changes the way we can simplify. Okay, let's try this one. The thing that's different about this binomial is we have subtraction. So what is the row of the triangle that we're going to use? Let's see, exponent 0, 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, 6. So we're going to use this row of the triangle as coefficients to do this expansion. Okay, so let's take a look. Row the number from the triangle. A goes to the 6th, and negative b will start at 0. Okay, triangle number, A goes down, B goes up. Triangle number, A goes down, B goes up. Triangle, A goes down, so he goes 6, 5, 4, now we're at 3. And B was 0, 1, 2, now we're at 3. Okay, 1, 6, 15, 20, now we're back to 15. A goes down, B goes up, And we'll keep going down here. 6. A goes down to the first. Negative b goes up to the fifth. Until finally we have 1 times a to the 0 times negative b to the sixth. Okay, now let's clean this up. Our first term is just going to be a to the sixth. All right, that takes care of that. Now notice, if you start with negative b to the first, that's obviously negative b. Remember, it's like there's a -1 coefficient here for b. So we multiply coefficients, 6 and -1, and that makes -6 a to the fifth b. Okay, that takes care of that term. Now let's move down to the next term. This time when we square a negative number, it becomes positive. So when we do negative b raised to the second power, it becomes positive b squared. So my coefficients are all positive. 15 times 1 makes positive 15 a to the fourth b to the second. Okay, that takes care of that one. Now let's work on this term. Again, negative b to the third, when I raise a negative number to the third power, it stays negative. So again, it's like there's a -1 coefficient. So 20 times -1 is -20 a to the third b to the third. Okay, so you might already start to pick up on a pattern here. After the first term is always positive in these expansions. But after the first term, if you have subtraction in your binomial, this will be a subtraction sign. But then the signs should alternate back and forth. Minus, plus, minus. My next sign should be plus. Well, let's see if that works out mathematically. If you raise a negative number to an even power, it makes it positive. So my coefficient here will be positive 1. 15 times 1 times 1 is positive 15, a squared b to the fourth. And you can do these all across on one line, but I just don't have enough room. So with this sign being plus, then I should be shifting back to minus here, keeping up with my pattern. Minus, plus, now minus. Because when I raise a negative number to an odd power, it stays negative. So it's like 6 times 1 coefficient times -1. And that's -6 AB 5. And then finally, I should be going back to plus 1 times 1. When I raise a negative number to an even power, it stays, or it becomes positive. And so my final term will be positive b to the sixth. Okay, this will be my last example for this lesson. And once again, let's think of the row of the triangle that we will use. So hopefully you'll get really good at making these triangles. All right, so this row would take care of exponent 5. It's got 6 numbers on it, so this is the row that will represent our coefficients. So this problem's a little different because we have a monomial 2a as part of this first term, so I want to give you a little heads up and hopefully help you prevent a pretty common mistake here. So I'm going to do the row of the triangle. First term, 2a, it's going to be raised to the 5th power. The second term, b, is going to be raised to the 0. Okay, next number. This time 2a is going to be raised to the 4th, b to the 1st. Next number, 10. 2a is going to be raised to the 3rd, b, just make a little line here so I won't run into my triangle, b to the 2nd. Next number, 5 times 2a, see, 5, 4, 3, 2. And we're going to multiply that times b b to the third. Okay, so we got 1, 5, 10. Oh, that should have been 10. I'm sorry. Sorry about that. You probably caught that. So 1, 5, 10, and now I should have used this 10. Okay, now we're back to 5, 2a to the first, b to the fourth, and then I'll put my last term down here, 1 times 2a to the 0, b to the fifth. Okay. I want you to pay attention to what happens here, and I put parentheses around this term on purpose because I want to show you something that's very important. 1 times 1, of course, is just 1, but what this means is not only am I raising a to the fifth, most people get that, but you're also raising 2 to the fifth. So when I simplify this first term, it actually becomes 32a to the fifth. So be very careful. When you have a term that's a combination number and variable, we would call that a monomial, then both of these are raised to the power, not just the variable. Okay, let's take a look at this term. Well, the first thing I would do is simplify 2a to the fourth. And 2 to the fourth is 16. Of course, a to the fourth. So you put those together, and that becomes 16a to the fourth. And now we can multiply 16 times 5, which is 80. A to the fourth, b. All right, now let's simplify 2a raised to the third. Well, that should be 8a cubed. And now we can multiply 8 times 10 and get 80a cubed b squared. Okay, this expression 2a squared is 4a to the second, and 4 times 10 is 40a squared b cubed. 2a to the first is just 2a, and 2 times 5 is 10, a b to the fourth. And then finally, we have 1 times b to the fifth, and that finishes our answer. So the blue is our answer. Okay, I have it on 2 lines, but I think you get the picture. So that is, those are some examples of expanding binomials to given powers using the Pascal's triangle. And hopefully that helps you. And if not, if you have questions or if you need more help, come and see me during academic support.